The National Association of Realtors estimates that 23% of all homes purchased in 2004 were considered investment properties. If a sample of 800 homes sold in 2004 is obtained, what is the probability that at most 200 homes are going to be used as investment property? First, we try to extract the information and label them. Say, in this case here, this 23%, so this is P. So P is this 23% or 0.23. And a sample of 800 homes, so this is your N value. So N is equal to 800. And what is the probability that at most 200 homes are going to be used as investment property? So we have to find this probability that this P hat is at most 200 homes out of the 800. So 200 out of 800. So this probability we have to find. So now this sampling distribution of proportion would be approximately normal if the two conditions are satisfied. The first condition is that sample size should be less or equal to 5% of the population size. So here the sample size is 800, but the population size is not given directly, but we know that every year in the United States millions of houses are sold. So this 800 is definitely less than 5% of the millions of the homes that were sold in 2004. So we would assume that this condition is true. Similarly, the second condition is that, so N times P times 1 minus P. So in this case, so this should be actually greater or equal to 10. This is second condition. So we have N is 800 in this case, and P is this 0.23, 0.23 times 1 minus 0.23, and this is equal to 141.68, so which is definitely greater than 10. So it means that second condition is also true. So which tells us that the sampling distribution of proportion is approximately normal. So we can apply the normal distribution to answer this question. So first we have to figure this out. So we know that for sampling distribution of the proportion, so the mean of P hat, so this is the same as P. So in this case that is 0.23. And standard deviation of P hat, so that is equal to the square root of P times 1 minus P divided by N. So P is 0.3, so 0.23 times 1 minus 0.23 divided by 800, and that's equal to 0.01488. So next we draw this curve, because we know that it's approximately normal, so we draw this curve. Say this is our curve, normal curve, and its mean would be here in the center, so which is equal to mu P hat, that's 0.23. And we have to find this probability that P hat is less than 200 by 800, and this number is actually, if you simplify it, so that turned out to be 0.25. So our 0.25 would be here somewhere, so 0.25. This is your P hat. So when we have find the probability that p hat is less than 0.25 or 200 by 800, so it means that we are talking about this area. So this area here, this would be the answer to our problem, right? So to solve this one, first we find a z value corresponding to this p hat value. So z value, and z would be equal to p hat minus mu p hat by sigma p hat, and that's p hat is 0.25 minus 0.23 divided by sigma p hat. So this value here 0.01488, and that is approximately 1.34. So z value is 1.34. And then we would look this value. This would be corresponding to this p hat value, right? So here corresponding to z we label as 1.4, and we look this value, this area here under this curve on the left of this vertical line for z is equal to 1.34 from the table. So let me bring in a table here. So this is 1.3 here, and 1.30, 31, 32, 33, and 34. That would be the area under the curve. So that from the table, this area is 0.9099. This is our answer, and we would express this as that probability that the proportion of would be less than equal to that 200 out of 800 homes is equal to P of Z is less or equal to 1.34, and which is equal to 0.9099.